Welcome to this tutorial on concatenating arrays with NumPy's concatenate function. In this video, you'll learn how to join multiple arrays along an existing axis. This is a fundamental operation that you'll use frequently when working with NumPy arrays for data manipulation and analysis. Array concatenation means joining two or more arrays end-to-end along a specified axis. Think of it like connecting building blocks together. However, there are important rules to follow. First, the arrays you want to concatenate must have compatible shapes. Second, you can only join arrays along their existing dimensions. The result is a single combined array that merges all your input arrays. One of the great advantages is that this operation is both fast and memory efficient, making it ideal for handling large datasets. Let's look at the basic syntax of the concatenate function. The function is called as np.concatenate, and it takes two main parameters. The first parameter is a tuple containing the arrays you want to concatenate. Notice that the arrays must be passed inside a tuple with parentheses. The second parameter is axis, which specifies the axis along which to join the arrays. By default, axis is set to 0, which means concatenation happens along the first dimension. Let's start with a simple example using one-dimensional arrays. We create two arrays. Array 1 contains the values 1, 2, 3, and array 2 contains 4, 5, 6. When we call np.concatenate with these two arrays in a tuple, NumPy joins them end-to-end. The result is a single array containing all 6 elements, 1, 2, 3, 4, 5, 6. This is the simplest form of concatenation and works just like appending one list to another. Now let's explore two-dimensional arrays. Here we have two 2 by 2 matrices. Array 1 contains rows 1, 2, and 3, 4, while array 2 contains rows 5, 6, and 7, 8. When we concatenate along axis 0, we're stacking the arrays vertically, adding new rows. The result is a 4 by 2 matrix where array 2's rows are added below array 1's rows. The output shows all 4 rows, 1, 2, 3, 4, 5, 6, and 7, 8. Axis 0 concatenation is perfect when you want to combine datasets by adding more observations or samples. Using the same two arrays, let's see what happens when we concatenate along axis 1 instead. This time we're stacking the arrays horizontally, adding new columns. The result is a 2 by 4 matrix where array 2's columns are added to the right of array 1's columns. The output shows 2 rows with 4 elements each, 1, 2, 5, 6 in the first row, and 3, 4, 7, 8 in the second row. Axis 1 concatenation is useful when you want to add new features or attributes to your existing data. You're not limited to joining just two arrays. The concatenate function can handle multiple arrays at once. In this example, we have 3 separate arrays: array 1 with 1 and 2, array 2 with 3 and 4, and array 3 with 5 and 6. We pass all 3 arrays as a tuple to the concatenate function. NumPy joins them sequentially in the order provided, resulting in a single array containing all 6 elements, 1, 2, 3, 4, 5, 6. This is extremely useful when you need to combine data from multiple sources into one unified array. Let's recap the essential points about array concatenation. First, shape compatibility is crucial. All arrays must have matching dimensions except along the concatenation axis. Second, remember the tuple requirement. You must pass your arrays inside a tuple, not as separate arguments. Third, if you don't specify an axis parameter, the function defaults to axis equals 0. Finally, concatenate always returns a new array without modifying your original arrays, so your source data remains unchanged. Keep these points in mind, and you'll avoid common mistakes when working with concatenate.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.